Hi, everyone. Good morning or good afternoon, wherever you're joining us from. Thank you so much for joining us today for our Moving Past Legacy Data Virtualization with Starburst webinar. A quick housekeeping item. We are going to be leaving time at the end of the webinar for questions. So on your GoToWebinar control panel that should pop up on the right-hand side of your screen, there is a questions tab. So feel free to put any questions in there and we will answer them at the end of the webinar. So next, I would like to introduce our presenters and speakers today. So we have Matt Harris, who is Starburst's Field Engineering Director, and Jeremy Akers, who is our Pre-Sales Deployment Engineer. So without further ado, I will hand it off to them to get the webinar started. Thank you so much for joining us again today.
Thank you, Becca. As Becca said, I'm Matt Harris. I lead the field engineering team here at Starburst. I've been with Starburst now for a little over a year. Before that, I have experience at Databricks. Before that, I was at Cloudera, and then the first 5-6 years of my career in tech, I was actually focused on data virtualization. So my time has spanned data virtualization through big data analytics to the cloud. So first off, just to make sure we set a level, we do a level set on what data virtualization is, I wanted to walk through what we're going to be referring to throughout this presentation when we talk about data virtualization. So at a high level, data virtualization is a capability that allows analytics via virtual queryable views of your data. So whether the data is structured, semi-structured, whether it lives in a lake, whether it lives in traditional relational databases, the platform or data virtualization provides a single view into that data. It has become an overloaded term, so to make sure data virtualization in this context is really around data source access and query. There are other concepts around data virtualization that are more around infrastructure and virtualizing DevOps in particular, but this is data virtualization for analytics. So a couple key things that data virtualization focuses on when we talk about analytics. First off, it makes relevant data sources appear as if they were one place. Create a single point of access for data via a single query layer. Secondly, it gives the ability to abstract data. So being able to abstract the details of the underlying infrastructure, the underlying data sources, and allows you to create common semantic layer to that data. So if you wanted to rename a particular column, particular data asset or attribute, that's what we're talking about when we talk about abstracting data. Thirdly, data virtualization is usually referred to in terms of federating data. So while we're creating these abstraction layers and virtualizing the data, the other benefit is the capability to integrate data from multiple data sources into one. So for as an example, if I issue a query to a data virtualization platform, the source data that it's retrieving may be coming from one source is an Oracle source, one source is a data lake, one source is a Postgres source, or even other types of non-traditional data sources, whether it be something like a service bus or MongoDB or Kafka or something along those lines. And then lastly, one of the key things is to present data in a consistent format to the end users. This allows users to accelerate their access via BI tools, visualization tools, other tools that typically consume using JDBC, ODBC for connectivity or SQL, but also provide the access to other types of applications or developers using some of those same constructs. So a brief history on data virtualization. The first thing, what really drove data virtualization to be part of the data ecosystem? So a couple of the key drivers for data virtualization. First off, this rings true today as it did 20 years ago when data virtualization was first becoming something interesting in the market. The need to reduce the delays for accessing data that's processed by ETL before it lands in a data warehouse. So most organizations started seeing a need to say, what if I don't want to wait for a multi-day, multi-hour, multi-minute data pipeline to land data in a final resting spot? How do I get that data sooner? Secondly, slow time to market for new data sources and information. So even when data does exist in a data warehouse and it's at rest, the number of sources and the data types and columns that exist in that data are rapidly changing and evolving. So in order to get that new information, typically the process before data virtualization required an organization to rewrite or redevelop their data pipelines or ETL processes to allow that access. Secondly, in this area is also, as organizations have went through a lot of consolidation or mergers and acquisitions, as new business units came online, being able to integrate this data with others was oftentimes a very long and tedious task to be able to match that data, to be able to rationalize it. And data virtualization provided the ability to integrate that data on the fly, even if longer term, the end goal was to put that data at rest in a single place and do an ultimate physical consolidation. Another piece that we often see data virtualization used for was the ability to prototype data pipelines before they were used. So a pretty common occurrence in data or in ETL is that an end user, an analytic user, or a consumer asks for a particular view of their data they want to land in their data warehouse. The data engineering team builds the ETL pipelines, creates the processes, and then they deliver that data. And then somebody says, well, I want something a little bit different, or it isn't quite what I expected. Data virtualization provided the capability for end users to have direct access to their data sources. And then once they establish that these are the analytic views of the data that I need, then we can go back and make a decision if we want to turn those prototypes into a long-running pipeline, for instance. The next one, being able to access data from all sources. Oftentimes, non-traditional sources, whether it was sources other than a relational database or even big data and other types of data, these weren't originally intended to be part of some of these other pipelines. So in order to provide access to end users, data virtualization was often used to provide that real-time integration or direct integration for end users to get quick access to that data for analytics. Another key driver initially for data virtualization was to provide access to integrated data for service-oriented architectures. I will say that this is becoming less and less frequent as we start to see, more microservices in the way that data is delivered today via data lakes in a lot of these cases, but it still does hold true to a certain extent. And then lastly, an economic play was what drove the adoption of virtualization early on, which was, why do I want to build another data warehouse or invest in more storage when I may be able to satisfy my end user need by having direct access to sources via virtualization platform? So just to give a little bit of a timeline on the history of data virtualization, the first platform that really tried to tackle data virtualization, and at that time it was referred to as EII. EII was an acronym for Enterprise Information Integration. And this was originally done as a product by a company called MetaMatrix that was very focused on data access and this EII concept, a very heavy metadata basis. In 2003, Composite Software was founded, also to be focused on EII. This is where Jeremy and I actually both spent a number of years, which is where we come from for this background. In 2007, MetaMatrix was acquired by Red Hat, and the acronym shifted from really being this concept of EII into data virtualization, which adopted a number of other concepts that we haven't talked about previously, specifically around more analytic focus, a very heavy focus on rapid access to new types of data sources versus just looking at legacy traditional sources that exist in the enterprise, and so forth. In 2010, Denodo, which has been a company since 1998, pivoted a lot of their heavy shift from data mashup into data virtualization as they saw the needs of enterprises to be able to satisfy these capabilities. In 2013, we're going to talk a little bit here about Starburst as well, and where Starburst originated. In 2013, Facebook open sourced Presto. For those of you unaware, Presto was originally built as a platform to accelerate analytics for the data lake, in particular HDFS, the Hadoop distributed file system. And then later on, as we talk through here, Presto started turning into a federated data platform that also provides what we'd like to call is more modern data virtualization. In 2013, Composite Software was acquired by Cisco and integrated into Cisco Stack. In 2014, Presto introduced federated data access. So this is where the users at Facebook believed started to realize that even though they had a data lake that contained a massive amount of data, there was a need to introduce access to other data sources that maybe had not made it to the data lake, had not yet made it to the data lake, or that may never make it to the data lake depending on the data type. In 2015, Teradata became the first organization, the first vendor to really start making enterprise contributions to Presto. Their investments were very heavily around how do we create features around security, around usability, around access for enterprises instead of being solely focused on what satisfied just Facebook. In 2017, Tibco acquired Composite Software, the assets of Composite Software from Cisco. And at that point, they really put the focus on that product to enable their spot flyer, their own DV tools, or their own visualization tools. In 2017, Starburst Data was founded with a mission to really focus on providing a single point of access using data federation and data lake, high-performant data lake access for enterprises. In 2018, the Presto founders joined Starburst from Facebook, which allows Starburst to drive and contribute enterprise capabilities based on our customer needs and user needs to the open source, as well as continue to build on the platform, the capabilities that enterprises need that may not fall in the open source, for instance. And then this year in 2021, just for those of you who aren't familiar with Trino, just to give a little background there, Presto SQL became Trino. There was a number of reasons why there was a split in the open source ecosystem between Facebook's direction on Presto DB and the open source direction that was really enterprise focused with Presto SQL. And to thwart some of that confusion, there was a decision made to rebrand Presto SQL to Trino. And then also in addition to that, Starburst this year released Stargate, which allows cluster-to-cluster connectivity, enabling organizations to serve hybrid cloud environments, combinations of on-prem and cloud, and really also satisfy capabilities where organizations may have sovereign data needs to be able to make sure that data remains in one place, even though they want to take the advantage of federation and data virtualization, and be able to integrate that with other sources that may not have those same requirements or may have a set of different requirements. And with that, I will pass it off to Jeremy Akers to walk through the difference in Starburst versus traditional data virtualization.
Yeah, thanks, Matt. So like Matt, I started my career in data virtualization at Composite Software. I stuck it out at Composite through the acquisitions at Cisco and Tibco. So I ended up spending about a little over 10 years of my career working in the data virtualization space. So let's talk about what makes Starburst different in this space. So the real big difference that Starburst offers here is our MPP query and federation engine. So with Starburst, the engine was really built from the ground up to be MPP capable, right? So like we started out as a data lake query engine, and being able to query, very large, multi-billion row data sets was, key to any kind of query engine that would be able to, perform in that space. So with an MPP query engine, as you add nodes or you add CPUs to your existing nodes, you gain faster query performance as well as additional concurrency. So a single query can come in and utilize multiple nodes, multiple CPUs per node. And so as your cluster grows larger, you can actually query, a single query can hit, very large data sets and return results faster. Most of the legacy DB tools in the market today are still primarily SMP based. So what that means is, for the most part, one query will hit, we'll use a single thread on a single CPU. Now, there are some exceptions to that, obviously, like if you're doing certain types of unions, certain types of joins, there might be a case where, maybe you're using 2 or 3 threads. But for the most part, most queries on an SMT-based legacy DB system are very limited in the number of threads they can utilize. It's usually about 1 thread per query. So what that means is, as you scale up a cluster in a legacy DB system, your individual queries aren't going to run any faster, right? So as you increase the size and scale of your legacy DB cluster, you're going to be able to handle more users, which means you have more concurrency. But it's not going to make it so you can access, multi-billion row data sets and get query run times that return faster by adding more CPU. Now, we do have some DB tools in the market that do offer MPP as a feature on their website. If you look into the details of those solutions, they're usually an external bolt-on type MPP solution. And what that means is the DB tool itself is going to read data from the underlying sources, and it's going to pipe that data into an external MPP platform. And if you actually look at what platforms they recommend, they usually recommend Trino, which is the open source version of Starburst. So they're piping that data from the underlying data sources into that external MPP engine. So obviously this approach requires moving data from that source system, into that MPP system such as Trino, and then running the final query against that Trino or other MPP platform in order to achieve that MPP performance. So let's look at a diagram to kind of help illustrate this. So with a non-MPP architecture, right, your end user is going to submit a query. That query is going to go to a load balancer. That load balancer is going to then round robin that request to one of your nodes. And because there's no way to split this query up into smaller tasks, that query for the most part is just going to hit one CPU on that one node, and it's going to have single-threaded access to your underlying data sources. Now, if we compare that to the Starburst architecture, MPP architecture, here you have your end user submitting queries to what we call a coordinator, which is a special node in the cluster that coordinates and plans queries. The coordinator will then split that query up into smaller tasks that we call splits. And so one query can get split up into hundreds of splits. And those splits get divided across your multiple worker nodes. And then each worker node also ends up getting multiple splits so that you can utilize multiple CPUs and multiple cores on that one node. So here you can see like how the job is able to be massively parallelized across your cluster. And with that, you also gain multi-threaded access to your underlying data sources. So each one of those nodes is also able to make parallel connections to your underlying data sources and pull that data in chunks and get rows 1 through 1 million from on this thread, and rows 2 million to 3 million on this thread, and pull those rows in parallel from these underlying data sources. All right, so how does this affect your concurrency? So like I said, with Starburst, our engine has been built from the ground up to focus on MPP principles to provide the scale for performance and concurrency, right? So this isn't like a bolted on after our engine was built from the ground up to support this. So again, as you add nodes, as you add CPUs to your cluster, you're gaining an increase in both your performance of your individual queries, as well as the number of concurrent queries that you can run at the same time. With the legacy DB tools, the base query engine, which is not MPP capable, does offer horizontal and vertical scaling to increase your concurrency. But if you want to increase the performance of your queries, you have to use their bolt-on MPP option. And this kind of negates, right, the benefit of their horizontal scaling, because as you add additional nodes to that legacy that legacy DB cluster, you're not going to gain the benefit of things like multiple parallel connections to your data lake and multiple parallel connections to your relational data sources. So as we're running these queries, if your using the bolt-on MPP option, you're still using a single thread to pull data from the underlying source, and you're using a single thread to pipe that data into some other MPP platform. So you've got a single thread both directions there. And then you're also increasing the overall network traffic on your network, which is also going to result in lower overall concurrency. So with Starburst, you're going to achieve much higher concurrency levels. All right, so let's also talk about some differences around like scalability. So Starburst is capable of scaling to thousands of CPUs in a single cluster. You can have hundreds of worker nodes. These multiple worker nodes, again, are going to work in parallel to directly read data from your various data sources. And with this, data doesn't need to be piped into any external system. We also offer auto scaling, which I think is a really big advantage that we have over most of the legacy DB tools out there. So auto scaling means that your cluster doesn't have to be sized for your peak periods 24/7. So with a cluster that scales up and down, you can have it scale down to very few worker nodes during those hours where you have very little demand on your system, and you can have it scale up during peak periods. So instead of paying for 100 worker nodes 24/7, if you only need 100 worker nodes for a couple hours during your peak period, this greatly reduces both your infrastructure costs as well as your licensing costs, because we're licensing the software on a CPU hour basis. So you're only paying for the CPU hours that you're using. So when you're scaling down, you're not only saving infrastructure costs on your cloud provider, but you're also saving licensing costs. With your legacy DB tools, queries are directed to a single node to read data, process it. Again, this is typically single threaded, and return it back to the user. So here, there is usually no auto scaling. So what that means that the cluster, if there are certain hours of the day that you need to have 100 nodes, you have to have those 100 nodes running all the time. So you're paying for a lot of infrastructure and a lot of licensing that you're not necessarily using all the time. And because of the lack of MPP, we find that data virtualization is the legacy DB tools are primarily being used, for small data type applications to serve front end and departmental analytics. So another difference that we offer is we have the Stargate connector that Matt mentioned earlier. What the Stargate connector allows you to do is you can have a Starburst cluster on premise, a Starburst cluster in AWS, a Starburst cluster in Azure. And this connector allows you to connect these three clusters to each other. And then you can query the cluster that is closest to you as the user, right? So if you're an on-premise user and you're using an on-premise application, your queries can hit the on-premise cluster, and you can reduce the amount of data that's being moved across the cloud, and that will increase your latency of your queries, so you get faster response times, and also decrease your cloud spend on network traffic, because we're able to push down operations into these clusters to reduce the amount of data that is being pulled back from each cluster. And then I think another key point here is that most of these legacy DB tools don't have native object storage connectivity. They usually require some sort of plugin, which is again usually single threaded. So where Starburst MPP engine can make multiple parallel connections to a data lake to retrieve billions of rows very, very quickly. The legacy DB tools usually rely on this plugin, which is often a secondary piece of software that has to be installed on another server and more infrastructure. So that greatly impedes the performance that you can get querying very large data sets through a data lake on a DB tool. All right, so let's take a look at some architecture diagrams. So with data virtualization, you've got your client tools, which query the DB layer, and then the DB layer is going to then query your operational databases, your non-relational databases, streaming data, and then it also can query things like Teradata and Snowflake for data warehousing. But the difference here is that for like data lake access, they usually are going to recommend putting, a Spark cluster Presto cluster or Trino cluster, something something that's MPP capable and something that's got native data lake connectivity, and they're going to use that to access the data lake. And this is also where if you need to run queries that achieve MPP scale, that MPP work is going to be pushed into that Trino cluster or that other MPP architecture that's being used off to the side there. So that's that plugin, that external bolt-on plugin that I was talking about that's being utilized there. Now, if we compare that to the Starburst architecture, you can see that there's only one layer here. There's no bolt-on add-on. Everything goes through Starburst. So you have federated access between your data lake, your data warehouse, your non-relational databases, your operational relational databases, streaming data. All of that flows through that single Starburst layer with no need to have any other add-ons. So we like to say, let's eliminate the middleman and just use the tool that can do it all. And with that, I'll pass it back to Matt to discuss how we work with data mesh.
Thank you, Jeremy. And a couple other things I'll add here that just to kind of hit on. And in addition to be able to provide access to all these sources and provide the MPP capability, there's a number of other things that really enable enterprises to get value out of their data. In particular, providing a single secure access layer that can provide fine-grained access control across these sources, in addition to column and row level permissions. Having a single point of access or a data consumption layer also provides the capability to do things like data obfuscation, data masking at query time. And the really interesting thing is that in traditional data platforms, adding those type of capabilities creates a performance hit. The inverse is true with Starburst, because when you're adding fine-grained access controls at a user or group level, Starburst takes that information and recognizes that its cost-based optimizer can do more intelligent things. If you have filter criteria that's defined, for instance, that a user or a group can't access a particular region, a particular data set, Starburst will in turn modify the query on the fly that it's making to the underlying sources and provide that information as a predicate, which ends up putting less stress on the underlying data source and moving less data over the network to be processed for the ultimate result set. Just a couple things I want to hit there real quickly around secure access. And with that being said, I talk a little bit about the data mesh. If people on the call aren't familiar with the data mesh, the one thing I would say first off is that I think traditionally data virtualization has been somewhat considered a niche technology and often viewed as a point solution, usually very project-based or buried into a particular set of users or particular set of use cases. With the data mesh technology and the data mesh concept, what organizations have started to think about is how do we take advantage of our entire data sets and our much larger data world? Because data is now transitioning from being just a pure place to store information and considered an asset into turning data into products. This is really the evolution of data usage within an organization and within large enterprises. And really what a data mesh, if you're not familiar, I recommend doing some research on Zhamak Dehghani, who really pioneered the thought process behind data mesh from ThoughtWorks, and has written a lot of information about the various concepts that go into data mesh. I only had a few of them here, specifically around analytics. But the key thing is data mesh is built to really address the historical failure of monolithic data architectures, right? The siloed approach that most everybody is used to, and really enable self-service for organizations. When people talk about data mesh, other common terms that you may hear used are things like a global semantic layer, a data marketplace. These are types of implementations of data mesh. They may not be full implementations, but usually their organizations are thinking very similarly in the way that they want to access and use their data. Another key concept around data mesh is this capability of, because data is spread out all over and we have a large number of enterprise users, it's really, really important to take advantage of distributed system architectures in those platforms to be able to support the scale and the concurrency needed for organizations. Rather than focusing data usage on the intended source of data, data mesh really focuses on the intended access and the use cases that are data-driven or information-driven for the consumer. There's a couple key principles that come into data mesh. One is this concept of the domain-driven architecture. And what this really is that rather than a business unit owning a data source, a business domain owns data and the data domain end to end. So this could be a combination of data, this could be a particular insight, and rather than passing this off to centralized IT, the idea is that that particular group or that particular business unit owns that insight to that data. The second principle is data as a product versus data as an asset. So organizations are starting to think more about how do we consume data instead of how do we create it, and how do we use it to make better decisions. As somebody who's been in this space for a long time, I know that myself and others in this space have very often been thinking this way. What's really great is now that larger organizations and enterprises are starting to think about this at a much larger scale instead of for point solutions. The third thing here is really this concept of self-service access to data and self-service as a platform concept. So how do we make data discoverable, accessible, and shareable across an organization? And then also federated governance and compliance. So with data being spread and accessed from across an organization, how do we ensure that the information is governed? How is it managed? How is it cataloged, and so forth? It needs to make sure that that governance and those governance attributes follow the data instead of being tied to a particular system. And then lastly, another big thing about data mesh is that it's very purposely technology and tools agnostic. So in data mesh, Starburst, we'll talk about Starburst being the analytics engine for the data mesh, but data mesh is very specifically around this is the type of technology you need, and leaves it to organizations and providers like Starburst to really define how we fit within this ecosystem. So what are some of the key technologies that make up a data mesh? What central IT does need to provide in order to satisfy a data mesh is, first off, data platforms are not going to go away. So being able to store the data in one place or store the data in multiple places is very important. This concept of a scalable query engine that is storage agnostic is very important, where we fall into data federation, data virtualization, and more modern analytics architectures. An orchestration capability, which really schedules data processes, controls ETL. You'll see that some of these are part of what's made up a traditional data ecosystem. However, oftentimes they're not very well integrated or thought collectively as a single platform from an enterprise standpoint. This concept of an abstraction layer, hiding the complexity of the underlying data sources away and the integration and what needs to be done to transform those, to integrate them on the fly, and so forth. Concept of a federation layer that we've talked about, being able to execute queries across multiple platforms in parallel. Global authorization at a security level. Be able to enable machine learning, AI, data science for end users, and then also auditing and monitoring tools. If we're going to give access to all of these beautiful nuggets that organizations want to access, how do we make sure that we're able to understand what people are asking, what they're doing, how they're using their data? And then on the domain side, which is really the business-focused portion of data mesh, it's really this concept of data cataloging. How do we provide data lineage so end users can understand where data comes from, the processes it's went through to be able to ensure that the data is valuable and is actually is truthful, if you will. The concept of data discovery and observability. Organizations need to understand how your data is being used, how people understand your data, how people are using it, and who is using it. And then data science and BI tools fall on the domain side versus the IT side. This is this concept of strong self-service mindset, and then also security for authentication encryption based on their own data usage and their own data policies. So a couple key reasons why we talk about Starburst being the analytics engine for the data mesh. First off, Starburst provides a single point of access to distributed data and a single data access layer. That can be an enterprise deployment across thousands of users and thousands of different types of data sources. There's no need to continue this kicking the can down the road of let me move my data somewhere else, let me create another single source of truth and invest in more infrastructure. The idea is take advantage of the assets you have, just make them visible and consumable by end users. Starburst provides an analytics engine for the data mesh architecture. Another big thing is that they must have an analytics engine capable of both federating data and being able to federate it across big data scale. And this is really important when we start talking about MPP architectures, as Jeremy explained earlier. Starburst empowers self-service analytics for business domains. Starburst provides this real-time access. You don't have to wait for data to be transformed or migrated to another source. You can get organizations get access directly to that data from the get-go. And then Starburst hides infrastructure complexity from the domains. While data mesh really talks about creating a invisible wall or an abstraction at an organization level between storage and access, Starburst provides that capability to hide that complexity and also provide capabilities around infrastructure management and cost management as well. And then lastly, Starburst is an open technology. Starburst is an engine, decided early on, and Trino and Presto as precursors, that SQL is the language that people have been using for data for 40 years. It's well known, it's well trusted, it's well adopted across the entire ecosystem of tools, of visualization tools, BI tools, ETL tools, application developers, whatever that is. Starburst conforms to ANSI SQL while being able to take advantage of open technology under the stack, which allows it to integrate easily with other tools and platforms within the ecosystem. So with that being said, definitely appreciate everyone's time, and we will turn it over for any questions that we may have, Becca.
Yes, so I think this was from a slide, a couple slides back, but the person asked, what about 1, aggregation pushdown, 2, semantic layer, 3, data lineage, and 4, data catalog, question mark.
One second, let me see. Can you, I can't see the question here. Can you repeat that?
Sure. What about 1, aggregation pushdown, 2, semantic layer, 3, data lineage, and 4, data catalog?
Yep. Jeremy, do you want to take that, or do you want me to? We can tag team it.
Yeah, we can play team it. So the first one was aggregation pushdown. So
Yep.
that's a good point. So our query engine does support pushing down aggregations. We support pushing down joins. We support pushing down predicates. So operations that will reduce the number of rows being returned across the network. We are able to push those operations down. Semantic layer, that's another thing that we support doing. So you can create semantic views in the Starburst layer to provide a semantic view for your end users. I think the third one you said was data lineage. Is that right?
Yes.
Yes. Sorry. Okay. Yes.
So for data lineage, that's not something that we offer out of the box, but we do offer integration with all the the major players in the space that offer data lineage. So one of the advantages with that, right, is with if you're using You know, one of the big players in the space who offer data lineage, those tools can get data lineage from, you know, any data source you have. You're not limited to just getting lineage from a single product. Whereas the DV tools do offer data lineage in the product, but that lineage is limited to only those data sources to which the DV tool itself is connected to. So you don't have like you don't get necessarily an enterprise-wide, you know, look at your lineage unless you somehow manage to get every single data source in your enterprise connected into that DV tool. And then remind me what the fourth one was.
Data catalog.
Data catalog, yeah, and the same story there, right? So we don't offer our own data catalog. We work with, again, like all the major players in the space who offer data catalogs. And again, like it's the same, you know, the same story where, you know, the DV tools that do offer data catalogs built in, the data catalog is limited to only those assets that are available inside the DV tool. Whereas, you know, when you're using, you know, a larger data catalog product, you're able to get, you know, access to those resources that are available inside Starburst, and as well as any other resources across your enterprise. So you're not limited to only seeing catalog items that are inside, you know, the DB environment, basically.
And whether those catalogs are, you know, we often see integrations with, you know, tools like Calibra or Elation or some of the more traditional cataloging tools, whether it be, you know, one of the large vendors that has their own, or even something more modern like a Munson, that users allow a lot of discovery and scraping logs to really interpret and figure out the lineage and the usage patterns and help governance. Those are all common plays. Going along this concept of data mesh I've talked about, which is much more looking at data assets as an enterprise-wide case. Most organizations are, you know, have these tools in place to manage lineage and cataloging at an enterprise scale. So our view has been to integrate with those and make sure that they're able to take advantage of our technology and we're able to use information from theirs.
Yep.
Awesome, thanks guys. On to the next one. What about Azure compatibility with Starburst visualization? Can we create dashboards by connecting to Azure?
So for consumption, yeah, absolutely. So Starburst is platform agnostic, and this is both on the infrastructure side. So we didn't get into all of the deployment patterns today, but the Starburst can be run on any cloud. It can be run on-prem. It can be deployed either from a binary standpoint as well as in a Kubernetes deployment, which is a big driver with autoscale and being able to be very cloud friendly and service, you know, as a service friendly. And then from a consumption standpoint, the Azure tool set, once again, because we conform to standard JDBC, ODBC connectivity, we have customers that are consuming data from any number of BI and visualization tools, including things like Power BI and other tools in the Azure stack.
Awesome. Okay, looks like we just have one more question. What's the tipping point in terms of scale when you start to see major differences in Starburst versus a legacy data virtualization tool?
So I usually like to say that if your data volumes are large enough to justify having a data lake, like if you've got, you know, billion row, you know, multiple billion row tables, that's usually about the tipping point, right? So if you have enough data that you need a data lake, that's usually the point where you're going to start to really see the advantages of the scale of the MPP engine.
Awesome. Okay, well, it looks like that is it for questions for today. So thank you so much, Matt and Jeremy, for leading us through this talk today. And thank everyone for attending our webinar. We will be sending out a recording. And I also put in the chat a free download for our O'Reilly Data Mesh book that we have on our website. So if you're interested in data mesh, this was written by Zhamak Dagani. So there's a link in the chat as well if anyone wants to check that out. But thanks everyone again, and I hope everyone has a great rest of their day.
Yeah, thank you.
Thank you again, everyone, and thank you, Becca, for you know, running this.
Yeah, awesome. Thanks everyone.
Thank you. Take care. Bye-bye.